Okay. So you go.
Good to go? Okay, so I'm Michael Smith. I'm working at the University of Gothenburg out in Sweden, and I'm going to talk a bit about the effects of vibration and noise from freight on sleep. Let's talk about what sleep disturbance actually is, talk about the studies we've done, and show you some of the results that we have obtained in it so far as well. So ever since the late 60s, there's been a method of scoring sleep, which was then updated in 2007. And the way it works is, as the night goes on, each 30-second period is assigned a sleep stage. So looking at whether it's deep sleep, light sleep, and so on. And this is measured with by looking at the electrical brain activity using EEG. So looking at the actual characteristics of these EEG waves, looking at eye movements as well, and muscle movements. So we have different sleep stages over the night. So as the night goes on, we have these different cycles. So we start with wake as the lightest sleep stage, and we have rapid eye movement sleep, and then we have progressively deeper stages of sleep here. So light sleep here, then an intermediate stage here, which is S2, and then we have the deep sleep, or slow wave sleep, down at the bottom, which is considered to be the most important for health, for rest recuperation and memory consolidation and so on. So what is sleep disturbance? So we have an exposure, so we have noise, we have vibration, and these cause primary effects. So these could be event-related reactions in heart activity. These could be causing you to actually wake up due to these different exposures. We then have these short-term after effects, which are things like subjective assessments, so how people perceive their sleep to be. Did they think it was good quality? Did they feel rested? Did they feel tired? It can also have effects on their performance. And then there are potentially long-term after effects as well. So things like, there's been quite a lot of work done which has suggested that things like noise exposure during the night might be contributing to the genesis of cardiovascular disease. So we have these different, autonomic reactions. So we have things like heart rate acceleration, and there's been quite a bit of work done looking at the effects of noise on sleep, traffic noise on sleep. And so we see that, when we have an event start, we see these, these biphasic response if they remain asleep, so rapid increase in the heart rate and then a deceleration to below the baseline. Then if they actually wake up as well, we have this quite severe increase in heart rate. And these heart rate reactions are considered to be potentially pathogenic. We also have things like cortical arousals and awakenings. So this is things like whether you wake up during the night because of an event, having abrupt shifts in EEG activity, and these arousals, as they're called, are considered to be quite a good indicator of sleep fragmentation in general. And they might not necessarily lead to an awakening directly, these short ones, but they might still end up in sleep being fragmented over the course of the night. And again, for work done on the effects of noise on sleep, so we're looking at the risk of an event causing an awakening here. We see that for railway traffic, as the noise level increases, the probability of these events causing an awakening is higher than for other environmental noise sources such as air traffic, road traffic. So how do we actually measure sleep? We use something called polysomnography, which involves attaching electrodes all over the scalp, on the corners of the eyes, to monitor the brain electrical activity, the eye movements and so on. Also have a couple of electrodes here, where we actually look at a couple of ECG electrodes looking at the heart activity. And then you also, typically a lot of studies involve recording so respiratory movements, so looking at breathing rates, things like that and so on. Blood oxygen measured with a finger pulse sensor like we have there. And this measures the objective sleep parameters. And from this we can, from the data we recorded, we can look at the time they spend in each sleep stage, so how much deep sleep they're getting at night, for instance. We can look at the sleep efficiency, so how much of their time in bed are they actually spending asleep. how much are they actually how much time are they spending awake after they originally fall asleep? How long does it take them to fall asleep in the first place? How long does it take them to actually initially get into REM or deep sleep? How much does their sleep actually change during the night? So how many times do they move from deep sleep to a lighter stage or vice versa? And can look at the number of arousals and awakenings during the night. There's also subjective assessment of sleep, which is used to obtain things like sleep quality, self-rated disturbance, self-reported awakenings, as I mentioned before, how tired they feel, how easy they thought it was to sleep. And these are generally measured using questionnaires. So in our sleep studies, for instance, we gave them questions each morning which they had to complete, where they would answer a series of questions in order to evaluate all these different subjective measures. Just got our questionnaire here. So previous studies with noise, for instance, this is only for rail traffic, find that increasing noise level reduces the amount of REM, and also increases the amount of wakefulness, so how much time they spend asleep. Also see that for freight trains here, this is the probability of an event causing an awakening or shift to a light sleep stage. We see that for the, as the maximum noise level increases, freight trains in particular become much more likely to cause these reactions than passenger trains or aircraft. But there's been very little work done looking at the effect of vibration on sleep, specifically from railway. So there was a study done by Arnberg et al. Back in 1990, which was a polysomnogram study with only 9 people in it, and this was simulating heavy road traffic. So there were lots of events during the night, each of only 2 seconds in duration. And what they found was that sleep was more disturbed when the exposure was accompanied by vibration rather than just with the noise alone. And they also found that subjective sleep quality was lower when they had the higher vibration amplitudes during the night. There was also some work done in Sweden at the University of Gothenburg in the Tvåne project. One of the things so there were a series of field and lab experiments looking at the effect of vibration on sleep. And what they found is that actually increasing vibration amplitude from soft to strong had a significant effect on reducing sleep quality, causing more restless sleep. And there was also a tendency for higher vibration levels to enhance the disturbance due to noise during the night as well. And in lab studies, field studies, sorry, what they found is that we have sleep disturbance here, strong vibrations, weak vibrations there, with comparable noise levels. And what we found, or what they found, was that in areas with strong vibration, but similar noise exposures, the sleep disturbance was higher in the areas with high vibration. So what we've been doing, we have been conducting laboratory studies to specifically look at the effects of vibration from freight on sleep. So we've done 3 studies in total. The first one, we looked at the effects of vibration amplitude using subjective data and also looked at heart rate. The second one, we wanted to see how does the number of trains affect sleep, how does different vibration levels still affect sleep, and we also recorded objective data for that one as well. And in the third study, we wanted to try and figure out, okay, what part of a reaction is due to the noise exposure, what's due to the vibration exposure, how do these two interact together, because of course generally you have both, and try and disentangle what part of the response was due to each. And so in the studies we had a total of 59 people over 3 studies. And I'll talk about the actual vibrations we used in a second. So people would come in for 6 consecutive nights in the lab, want it to be as much like a home environment as possible, so they've got their own private bedrooms, they've got their own living area, to try and ensure that we've got the highest ecological validity that we actually can. And they were screened to make sure they didn't have sleeping problems anyway, and they were asked to start going to sleep at 11 o'clock at night, and then were woken up at 7 in the morning with an automated alarm call. And the exposures we used, we made 5 different trains in total. With the noise exposure was for actual 5 recordings of actual freight trains, which were low-pass filtered to correspond to being a closed window in the bedroom. And for each of these, we would then generate a vibration signal, which was an amplitude modulated 10 Hz sinusoid. And we had 3 different maximum velocities, which are all presented here. And we've been talking about the metrics, and this just gives you, these are all exactly the same vibration exposures, just presented with some of the various different metrics, just to give you an idea of how difficult it might be. But what we have here are perception thresholds for people in the recumbent position, which is when they're lying down, which of course they are when they're in bed going to sleep. And we have the lowest vibration amplitude here, which is these ones here. So that's about 0.46 millimeters a second unweighted. And then we have an intermediate value here, a moderate, which is about 0.8, and then our high vibration has a maximum amplitude at all. So yeah, we talked about the weightings earlier. We used the ISO WD weighting because we applied vibration in the horizontal direction along the length of the bed. 5 different noise exposures. And also, we changed the number of trains in some of the studies as well, which would of course affect the RMS VDV values for each of these 8-hour periods. So, in one study we had noise only, with 36 trains during the night. We also had nights with noise and the low vibration, 36 trains in the first study. And for all of these, I have the, I've got the VDV and the 8-hour RMS as well. So we also had moderate vibration with 20 trains and 36 trains. We had high vibration with 20 trains, 36 trains and 52 trains. And we also had nights with just the vibration only, so no noise exposure. So that was in the 3rd study when we were trying to disentangle what part of the response was due to which exposure. And so people would come in and we'd actually change the order that we presented the exposures to the different participants over the different nights, just to ensure that there was no habituation effects. So what we found, so looking at the heart rate, so in the first study we did, we see that in the high vibration condition, which is this thickest line here, we actually found that the overall increase in heart rate was significantly higher than when there was only the noise exposure. And also there was, as the vibration amplitude increased, also how quick this increase occurred was also affected as well. The second study, so this had nights with high vibration and moderate vibration, and 20 or 36 trains for each. So we combined the different numbers of trains together, and what we found was that in the high vibration we have again the thick line, and in the moderate vibration we actually see that the high vibration is causing a stronger cardiac reaction than the moderate vibration. And so we also looked at in the second study, we looked at the probability of a given event causing certain reactions. So one of the things we looked at was how likely is any given event in a night likely to cause a change to a lighter sleep stage, so possibly instance moving them from deep sleep to one of the lighter, less restorative sleep stages. And we also looked at EEG reactions, so that includes the arousals I mentioned earlier and also actual EEG awakenings as well. And what we found is that in the nights with the moderate vibration, when we then increased the vibration amplitude to the high vibration, the probability of any one given event causing this reaction, so causing them to move to a lighter sleep stage, increased as well. And of course, bear in mind that the noise exposure was the same for both. The only thing that was changed was the vibration amplitude. And we see the same thing for the in the night with the 36 trains. And although, and of course these are all higher than nights with no exposure at all. And although there is a slight decrease in the probability as the number of trains increases, because you have more trains in the night overall, you are still going to have more of these event-related reactions. And then we see the same pattern for EEG reactions as well. So we have awakenings, which are these blue ones here, and we see that as the moderate vibration, about 10% probability of any given event causing you to wake up. And then when we go up to the higher vibration, we see that in the nights with the high vibration 20 trains, around 20% probability of any given train causing you to wake up. And for the EEG reactions, so when we include arousals, you see the nights with high vibration, around 45% chance of, we've got to take away the chance of it occurring randomly anyway, so maybe about a 35% chance of these events causing you to have one of these reactions. I also looked at sleep as a whole. So one of the things we looked at was the maximum continuous time they spent in deep sleep. And we found that in the nights with the 36 trains and high vibration, this was actually significantly lower than the control nights and the nights with the moderate vibration. Look at how long did it take them to wake up for the first time. Again, in the night with high vibration, this is, they woke up much more quickly for the first time than in the control conditions. Also looked at the total number of times they moved from what sleep stage they were into a lighter sleep stage, and we see that this is actually this is high. This is significant in the high 36 compared to the control nights. We see that as the exposure, so moderate here, high here, we see that it is a general trend for these number of sleep stage changes to increase. So that was the objective data. We also looked at the subjective questionnaire data, and we combined all three studies together for this. So looking at their self-reported sleep disturbance due to vibration. So we looked at plotted this as RMS 8-hour acceleration, and we see that as the exposure increases, we see that the proportion reporting being disturbed increases as well. And much like with the annoyance, where the curves are plotted, whether they give a rating of 5 or more, we've used the same approach only for disturbance rather than for annoyance. And just to put this into perspective, these values here, the high vibration conditions, these are the moderate ones, and this is the night with the low vibration from the first study, which only had 12 participants in it. And so also we have these for, we have the maximum velocity. Of course, the maximum velocity was the same for the low, moderate or high, but changing the vibration number of trains isn't going to affect the overall max, but is going to affect the RMS. And so these are the proportion disturbed. We also have the proportion highly disturbed as well, calculated in the same way. Again, we see this, this increase in disturbance with increasing vibration amplitude.
But does it seem there that it's more regular with the max values compared to?
Well, of course, with the max values, we only have these, we've got the nights with no vibrations, so including the control, so we've only got these 3 points, so it's kind of limited by that. And yeah, so we're also looking at vibration disturbance, noise disturbance. So nights with noise only, which is this one here, people didn't report being disturbed by vibration at all. Nights with vibration only, which is this one here, people didn't report being disturbed by noise, but their overall disturbance was their overall. I don't know where I'm going with that. So we looked at sleep quality as well, So we only looked at the nights which had 36 trains, because that way we had more data to look at, because it was only in the second study we had nights with 20 trains. So we thought, okay, study 1, 2, 3 all had times of 36 trains, so look at sleep quality for these. And what we found was that in the nights with a high vibration, there was significantly lower sleep quality than compared to the control case, the noise only, and also the noise with the low amplitude vibration. So vibration seems to be impacting on their subjective sleep quality as well. So, yeah, again, looking at nights with 36 trains, we see that as the vibration increases, that their vibration disturbance is increasing, but then their disturbance due to noise is pretty constant. So we also looked at the effective number of trains. One of the things that we see is that nights with the 20 trains, people actually had a tendency to have higher sleep quality than in the nights with the 36 trains. So how many events you have during a night does seem to be impacting on their subjective assessment of their sleep as well. Yeah, so generally what we found is that vibration from trains is impacting on sleep, both objectively measured and subjectively measured. So we noticed this with physiological reactions, we saw event-related reactions, so things like the heart rate increase. We saw that their sleep macrostructures was affected as well, and also that, as I say, their disturbance increased with increasing vibration amplitude as well. So, yeah, that's it for me.